Beneath the shadows of Geneva, far below the world's surface, lies a stunning achievement of human innovation, and an unavoidable sign of destruction, the Large Hadron Collider, LHC. It stands as a marvel of intelligent analysis, allowing researchers to investigate the subatomic realm and triggering the discovery of the elusive Higgs boson, more commonly known as the God particle. This breakthrough has captivated the scientific community. As Brian Cox, a renowned physicist, once ominously declared, a hidden potential has been uncovered at CERN, sparking a wave of curiosity and concern. Could our quest for knowledge have taken us down a dangerous course? Have we chosen an uncertain future, possibly one that defies our understanding? Before exploring this startling detail further, it is necessary to take a look at the gigantic machine that is the Large Hadron Collider, operated by CERN. The LHC is a massive 17-mile-wide ring of superconducting magnets. It is by far the largest and most powerful particle accelerator ever built. It stands as the pinnacle of scientific accomplishment, capable of recreating circumstances that rival the universe's creation itself. This incredible apparatus allows scientists to explore the fundamental elements of the universe, but with such immense power, could it lead us to unanticipated effects, possibly even into the realm of the unknown and terrifying? Founded in 1954, CERN has become one of the world's most prestigious and vital research centers, with 23 member countries and a vast network of experts. While the LHC is its most high-profile project, it is only one part of a wide variety of accelerators and detectors aimed at comprehending the universe's smallest components. The LHC is a race to uncover the very foundation of existence. It speeds up protons to nearly the speed of light, sending them on a collision course that simulates the energy and conditions of the universe at its inception. The temperatures produced are millions of times hotter than the sun's core, while an intricate web of magnets directs these particles on their journey. At the same time, highly sophisticated cooling systems maintain the system's supercold environment, colder even than outer space. Furnished with 1,232 dipole A magnets that steer the proton beams and 392 quadrupole magnets that focus the beams just before they collide, another crucial type of magnet helps increase the likelihood of these powerful collisions. Essentially, CERN's mission is to collide particles with such precision that it is akin to hitting two needles 6 meters apart. The accuracy required for this operation is staggering, and the technology involved is unparalleled. The collider's concentric rings are placed deep underground to protect them from radiation's negative effects. To achieve optimal performance, the entire system is cooled to -456 degrees Fahrenheit, colder than the vacuum of space. This underground setup houses 4 distinct particle detectors, Atlas, CMS, ALICE, and LHCb, each serving a unique function by focusing on various aspects of particle physics. These detectors are equipped with enormous cameras that capture particle impacts, with experts constantly analyzing the data in search of the elusive Higgs boson, thought to be integral to understanding the very fabric of the universe. In many ways, studying the microcosm helps us unravel the macrocosm, like solving a massive, cryptic jigsaw puzzle. But as each piece is added, new inquiries and mysteries surface, reminding us that every discovery leads to another problem. The LHC is not merely a tool for science, it is an embodiment of human ambition, progress, and the relentless drive to comprehend the fundamental forces that shape our universe. Yet, once we enter the unknown, we must also confront the moral and existential dilemmas that accompany such bold investigation. What are the potential risks of delving into the unknown? Could our quest for understanding unleash forces beyond our control? Recently, a disturbing revelation sent shockwaves through the scientific community. Brian Cox, a former CERN researcher and a prominent voice in particle physics, made a statement that both intrigued and alarmed his colleagues. According to Cox, the goal of the LHC, to recreate a miniature version of the Big Bang, replicating the very event that resulted in our universe's birth, could result in unforeseen consequences. The collider's impressive ability to probe the Higgs boson and explore the enigma of dark matter, a substance that constitutes a substantial portion of the universe, could potentially unlock truths beyond our comprehension. While the idea of locating the darkest mysteries of the universe is exhilarating, it is also not without risk. The LHC recreates the extreme conditions present at the universe's inception, simulating temperatures, pressures, and energies unlike anything observable in daily life. It's as if we are peering into the precise moment the universe began. Yet such immense power brings with it immense responsibility. Consider the incident involving a Russian physicist, Anatoly Bugorsky, in 1978. Bugorsky was conducting research at the U-70 synchrotron at the Institute for High Energy Physics when a tragic accident occurred, a proton beam accidentally penetrated his skull, causing significant tissue damage. Yet, miraculously, he remained conscious and walked to seek medical attention. His experience serves as a stark reminder of the potential dangers associated with particle accelerators. The power harnessed by these machines should never be underestimated. Concerns about the LHC's capacity to create black holes, even though on a very small scale, have raised alarms among some academic communities. Black holes are regions in space with gravity so strong that even light cannot escape. Some scientists have expressed concern that the LHC might create a miniature black hole, one that might theoretically consume the Earth from within. While CERN researchers have reassured the public that any black holes generated would evaporate almost instantly and pose no threat to the planet, this theoretical possibility has nonetheless sparked fear and intrigue. The idea of a black hole being created by high-energy particle collisions has fueled intense debate and growing awareness of the risks associated with such powerful experiments. Understanding the mechanics of the LHC is crucial for grasping its potential to form a black hole. When protons are accelerated to nearly the speed of light and collide, the energy produced is so extensive that it can distort the fabric of spacetime itself. This effect could be compared to jumping on a trampoline, causing the surface to bend and warp. These distortions raise the unsettling question: during such shifts, could a black hole emerge? In the bizarre and perplexing world of quantum physics, where the universe's fundamental laws appear to defy logic, a theory exists suggesting that unknown aspects of our reality may be hidden within the very fabric of space. If such elements exist, the LHC could potentially tap into them, sparking the creation of a gravitational anomaly with the potential to form a black hole. This possibility has garnered attention from some of the world's most distinguished scientists, including the late Stephen Hawking. In his writings, Hawking warned of the potential dangers of the LHC, especially if the Higgs boson behaves unpredictably at high energy levels. Such an anomaly could bring about a catastrophe known as vacuum decay, which might not only destroy Earth but unravel the very fabric. As scientists at CERN press forward, driven by a thirst for understanding the universe's most elusive secrets, the ethical dimensions of their work loom large. What responsibilities do we bear when pushing the limits of natural law? Is there a line that, once crossed, leads us not to enlightenment, but to consequences we are unequipped to face? The pursuit of knowledge is often romanticized, yet the experiments conducted at the LHC are not confined to abstract theory. They involve forces and energies so great that they resemble those of the universe's earliest moments. With each experiment, we inch closer to truths that may rewrite the laws of physics, or even challenge the foundations of existence itself. And yet, among all this uncertainty, there remains a profound sense of awe. The ability to recreate the universe's birth, to glimpse the mechanisms behind creation, is something our ancestors could scarcely imagine. The LHC, in this regard, is both a window and a mirror, a window into the cosmos, and a mirror reflecting humanity's boundless ambition. However, even as the data pours in, and as discoveries reshape our understanding of time, matter, and reality itself, some caution that we must not mistake capability for wisdom. Knowledge without wisdom has, throughout history, led to peril. Voices from within the scientific community echo a sentiment that transcends discipline. Just because we can, does not always mean we should. In recent years, philosophical and ethical think tanks have begun to work more closely with institutions like CERN. Discussions now include not only what might be discovered, but what those discoveries might mean for humanity. Could technologies born from the LHC's research one day alter genetics, harness energy in unprecedented ways, or even affect consciousness itself? If the boundaries between known and unknown continue to blur, we may find ourselves not merely observers of the universe, but active participants in its rewriting. As we stand on the edge of understanding, the Large Hadron Collider symbolizes more than science. It embodies a pivotal moment in human history. A moment when our reach might finally match our imagination. But whether that leads to clarity or chaos remains to be seen. One thing is certain, the LHC has not only changed physics, it has changed us. With immense power comes a significant moral responsibility. As we continue to uncover the secrets of the cosmos, we must ensure that our quest for information does not come at the expense of our safety or well-being. The LHC is a powerful tool in our attempt to comprehend the universe, but it also serves as a stark reminder of the profound ethical considerations that come with attempting the uncharted. As humanity pushes the boundaries of scientific discovery, the LHC remains an extraordinary example of our desire to understand the universe. The sheer scale of the project speaks volumes about the ambition behind it. Over 10,000 scientists, engineers, and technicians from around the world work together to ensure the machine's success. The scale of the LHC's data collection is staggering, with experiments generating petabytes of data every year. The storage and processing power required to handle this immense amount of information demands cutting-edge technology that has revolutionized fields such as computing and data science. The experiments at the LHC go far beyond particle physics. They extend to areas like medicine, material science, and even environmental studies. The study of the Higgs boson, for instance, could have wide-ranging effects beyond our current comprehension. This fundamental component of the standard model of particle physics plays a significant role in providing other particles with mass. Without the Higgs field, the universe would be vastly different, with particles floating around in an empty, massless state. However, beyond the basic understanding of the Higgs, scientists are also keen to explore how the particle behaves under extreme conditions. These studies could lead to insights that impact everything from the development of new materials to understanding the fundamental forces that govern the universe. One of the other critical aspects of the LHC is its exploration of dark matter. Dark matter is an invisible substance that accounts for around 27% of the total mass and energy of the universe. Despite its immense presence, scientists have not yet directly detected it. Dark matter is the focus of many LHC experiments, which aim to expose its potential components by observing the behavior of particles created during high-energy collisions. If dark matter is finally understood, it might alter the way we perceive the universe, unveiling hidden dimensions of space-time and altering the foundations of modern physics. In addition to dark matter, the LHC is exploring other exotic realms, such as supersymmetry and the potential existence of extra dimensions. Supersymmetry is a theory that proposes a relationship between two basic classes of particles, bosons and fermions. This theory predicts the existence of superpartners, particles that have yet to be observed. The discovery of supersymmetry could open the door to a fresh perspective on the fundamental forces of nature, offering deeper insight into the interactions that govern our world. Furthermore, the LHC plays a crucial role in advancing quantum computing. By understanding the behavior of subatomic particles, researchers can gain valuable insights with the potential to transform the way we process information. Quantum computers, based on the principles of quantum mechanics, have the potential to address problems currently beyond the reach of conventional computers. Technologies created specifically for the LHC's experiments, such as specialized detectors and advanced computing algorithms, have already influenced and advanced the field of quantum computing, paving the way for future breakthroughs. Despite its undeniable benefits, the LHC's work also raises fundamental questions about the future of humanity. The search for the unknown can be thrilling, but it also comes with the obligation of considering possible unintended consequences. The very technology that drives the LHC could be used for purposes that may be harmful to humanity, such as in the development of advanced weapons or creating scenarios that spiral beyond our control. Ethical debates surrounding the LHC are not limited to risks of catastrophic events like black holes or vacuum decay, but also include the potential application of the research. How do we ensure that this information is utilized responsibly, and that the pursuit of discovery does not inadvertently lead to harm? As we explore the significance of participating in the unknown, ongoing discussions must address the equilibrium between scientific progress and ethical responsibility. The global nature of the LHC's work requires the cooperation of multiple countries, each with their own values, priorities, and concerns. Transparency in research, accountability, and international collaboration will be essential to ensure that the knowledge gained through these experiments benefits humanity as a whole, rather than causing unforeseen damage. The work of CERN through the LHC serves as a reminder that scientific achievement must always be tempered with careful consideration of its broader consequences. Another issue of concern is the possibility of unanticipated ecological impacts of particle accelerators. While the LHC is a relatively contained environment with no immediate large-scale environmental effects, the energy requirements of these machines are significant. The environmental footprint of particle accelerators, especially those requiring massive amounts of electricity and producing heat, could strain natural resources and ecosystems. The energy demands of the LHC are immense. Although efforts are being made to use renewable energy sources and improve efficiency, the broader question of sustainable scientific exploration must be addressed. Ultimately, the path forward will require a delicate balance. The LHC represents humanity's drive for knowledge, exploration, and discovery. However, with every scientific breakthrough comes the need for ethical reflection and responsibility. The risks involved in these kinds of tests cannot be ignored, but the potential rewards could reshape our perception of the universe in ways we can only begin to imagine. As we continue this journey into the unknown, the focus must be on ensuring that the pursuit of scientific progress is conducted in a way that is safe, responsible, and beneficial for future generations. In conclusion, the Large Hadron Collider is far more than just an instrument for scientific research. It is a symbol of humanity's quest for knowledge and our never-ending fascination with the nature of existence. The questions raised by the LHC's work are profound and carry important moral and existential considerations. However, the LHC also demonstrates that, through collaboration and careful oversight, humanity can unlock secrets that have the potential to change the course of history. As we stand on the precipice of these brand new findings, we must remain vigilant, mindful of the potential risks, and committed to using the knowledge we uncover in an ethical manner. In the end, the search for knowledge must always be guided by the responsibility to protect our future. This responsibility is not solely in the hands of scientists and engineers, it belongs to all of us. As global citizens, we must foster a culture that values not only innovation but also introspection. Public engagement, education, and ethical discourse must accompany scientific advancement, ensuring that we collectively understand both the possibilities and the perils of what we pursue. The Large Hadron Collider represents one of humanity's boldest steps toward understanding the fundamental structure of our universe. But the true measure of our progress will not only be in the particles we discover or the theories we validate, it will be in how wisely we choose to apply that knowledge. Science must walk hand in hand with wisdom, not racing ahead without regard for consequence. In the years to come, the questions we face will only grow more complex. Will we be able to responsibly harness discoveries that could redefine life, matter, and even time? Will we build systems of governance and cooperation strong enough to handle the power such knowledge brings? These are not just scientific questions, they are human ones. And so, as we continue to peer deeper into the unknown, let us do so with humility. Let us recognize that while the universe may be vast and full of secrets, our role within it is one of stewardship, not dominance. In honoring that role, we may ensure that the knowledge we gain not only changes our world, but uplifts it.